Hey there, Science 10 people. So today we're going to talk a little bit more about acids, but we're also going to talk about bases and pH. So at the top here, just listed some of the properties of acids and bases. So as I've mentioned a few times, acids begin with H. So when we talk about H, we're talking about hydrogen. And in particular, we're talking about H plus ions. And that's a really important property of acid. Its ability, or it's the fact that it produces H plus ions in solutions, is what gives it all of its properties. Bases, on the other hand, end in OH, and again we're talking about hydroxide. So this is one of our polyatomic ions called hydroxide, OH minus. So bases end in OH, and the positive ion is always a metal. So the positive ion in acids is always H, which is a nonmetal. The positive ion in bases is always a metal. So there's magnesium hydroxide, sodium hydroxide, and so on. All of those are bases. I'm going to talk at the bottom about the pH scale, but one of the key identifiers of acids is that they have a pH lower than 7. So it's a scale of 1 to 14. Anything less than 7 is acidic, and bases, on the other hand, have a pH that's greater than 7. So anything higher than 7, we call that basic, or it's a base if it has a pH that's greater than 7. As I mentioned above, acids produce H plus ions when they're in solution, and bases produce OH minus ions in solution. And I said that that's what gives them their properties, and that's actually what this pH scale is all about. So acids and bases create neutral solutions when they're mixed together. So when we talked about neutralization reactions, that's exactly what's happening. So if we look at the pH scale, which I've mentioned ranges from 0 all the way to 14 at the other end, 7 being right in the middle is our neutral solution. And water, if it's distilled water, will have a pH of 7. So what the pH scale is a measurement of, it's a log, but it's a mathematical relationship that is really identifying the concentration of H plus ions, or hydrogen ions. So the more hydrogen ions that are in solution, the lower the pH is going to be, and the more hydroxide ions that are in solution, the higher the pH is going to be. For our purposes, as long as you know that if it's less than 7, it's acidic. If it's more than 7, it's basic. And the good news is this diagram that I've taken right here is actually one of the pieces of information that you get for your exam. So the Science 10 exam comes with data pages, and this is one of them. So if you look through it, there's just kind of a series of just regular everyday items. So stomach acid is, it contains hydrochloric acid, and it has a pH all the way down at 1. So the lower the number, kind of the more caustic the acid tends to be. But again, if you see number 2, we've got lemons. So citric acid is down there at a pH of 2, but it's at a low concentration. So it's not going to burn your skin, but you know, if you've gotten it in your eyes, then yeah, it's definitely not going to feel too good because it has that low pH. If we go over and look at the other side, we've got some different items. So we've got soap, we've got bleach, we've got a few different regular household items that are basic, meaning that OH minus ions get released in solution. So if it's higher than 7, it's basic. If it's lower than 7, it's acidic. And again, this very helpful piece of information you get to have with you on the exam. Alright, I think that's about it for acids and bases and pH for today. We'll talk about indicators on another day. Thanks, team.